This is your Chapter 7 exam review video, and the first 4 questions that you're asked are identifying if this is direct or inverse variation. So just a reminder, I wrote the equations at the top, and those are important to know. These are on your equation sheet, but you do have to know how to solve for K. When I look at number 1 and number 2, I think the easiest thing to do is try to identify when it's y equals what the equation looks like. That to me makes the most sense. So I'm going to go ahead and solve for y, and I'm going to do that by dividing by x. So y is equal to 5 over x. So if this is the equation, it looks like this is going to match the inverse equation, and that would be your answer. This is an inverse variation. Number 2, to get y alone, I'm going to divide by 5, and so I get y is equal to 6x over 5. And because x is in the numerator, this would be direct variation. So that would be your answer. Looking at the next 2, we are going to figure out, I'm going to look at what k is equal to, and I'm going to ask myself, like, do I have to multiply or divide to be the same? And when I look at my x and y pairs, I realize that if I divide them, y over x, they all are 5. And so this means that when you divide them, this is direct variation for your equation. Looking at number 6, I know that I can't divide them, but when I multiply all of these, I get 32. So x times y is equal to 32, and that matches the inverse variation. The next problem that we did do is number 6. Nope, we did that. So number 9. So looking at number 9, it says the variables x and y vary inversely. So it says x is equal to 5 halves and y is equal to 18. So y is equal to k over x, right? It said that they vary inversely. And so I'm going to write an equation and then I'm going to solve. So 18 is equal to k over 5 halves. And in order to move that to the other side, I'm going to multiply both sides by 5 halves. And I'm going to get that k is equal to 18 times 5 halves. So k is equal to 45. So I'm going to write a new equation. Y is equal to 45 over x. So that's my equation, my inverse variation equation. And then it says to solve for y when x is -3. So I'm just going to plug that in, and I would get y is equal to -15. The next one is number 12. And it's asking us to graph the function. So y is equal to 1 over x plus 5 plus 2. And again, use your calculator, find the table, and then it's going to state the domain and range. So I'm just going to do a rough sketch because I think that you guys are capable of finding the accurate one on your own. But I'm going to go ahead and plug this in my calculator. And when I do that, I get an asymptote at -5. 1, 2, 3, 4, 5. So roughly there's an asymptote there. There's also an asymptote at 2. And then it looks something like this and this. So again, rough sketch, you would plot specific points and label your asymptotes if needed. Okay, so the domain is all the real numbers except the asymptote. And so I am going to write this as -infinity to -5 in union with -5 to infinity. Remember, we use parentheses when it does not include a number and brackets when it does. And then I'm going to do the same thing for the range. That would be -infinity to 2 in union with 2 to infinity. So remember, domain is x values, the range is the y values, and we're going to use these values. Again, this is the line y equals 2 and x equals -5. Those are going to influence your domain and range. Number 16. Flip the page. All right, so we're going to find the product. So let me copy this down. We have 80 x to the 4th over y cubed multiplying by xy all over 5x squared. So you can cross reduce right now, or you can combine them all. And sometimes I like to combine first. So 80 x to the 5th y all over 5x squared y cubed. And sometimes I think seeing it in one fraction just makes it a little bit easier. So I'm going to go ahead and reduce. So 80 divided by 5 is 16. And then 5x is on top, 2 in the bottom. I subtract my exponents. I have 3 left on top. And then 1y on top and 3 on the bottom. I subtract them and I have 2 left in the denominator. So 16x cubed over y squared. It also, it doesn't say to state the restrictions, but we probably should. And in number 16, both x and y cannot equal 0. So we get restrictions, again, just a refresher, is from any variable in the denominator. Number 17. So x minus 3 divided by 2x minus 8 times 6x squared minus 96 all over x squared minus 9. So I'm going to factor as much as I can. So I'm going to get x minus 3, that stays. On the denominator, I can remove 2, x minus 4. 6 and 96 are definitely factors. And when I do 96 divided by 6, you get 16. So this is 6x squared minus 16 all over x plus 3, x minus 3. And again, I can actually simplify this. So one more time, I get x minus 3, 2 x minus 4, 6, x minus 4, x plus 4, the order doesn't matter, all over x plus 3, x minus 3. So looking here, I'm going to reduce as much as possible. And remember, when we can reduce, you can reduce one factor on top, one on the bottom, even if they repeat more than that. So 1, 1, -4, -4. And I can actually reduce 6 over 2 is 3. So I'm going to have 3. And then I'm left with an x plus 4 on top. And the only thing on the bottom is an x plus 3. So that would be your final answer. Oh, and then restrictions. So anything in the denominator is a restriction. So I go back to this beginning step and I'm going to do all 3 of those. So x cannot equal 4, x cannot equal 3, x cannot equal negative 3. Number 19 is similar, and I'm actually just going to factor as I go so I don't have to write down the whole thing. So if I factor the numerator, what multiplies to 40 and adds to negative 13? So x minus 8, x minus 5, all over multiplies to negative 15. So this would be x minus 5, x plus 2, plus 3. Oops. And then, again, we keep, change, flip. So I'm going to put a 1 on top and then flip the second fraction because we're dividing. And I get x minus 8, x plus 3. Again, because I've factored, I can reduce. So I'm going to reduce what I can. And I'm left with 1 over x plus 3 times x plus 3. And we can rewrite this as 1 over x plus 3 squared because it's happening 2 times. 23. Okay, looking at number 23, we're adding. So remember, when we add or subtract, we need a common denominator, so that's something to keep in mind. So I get 5x over x plus 8 plus 4x minus 9. And I'm going to factor the denominator, so this is x plus 8, x minus 3. So again, in order to combine these, I need a common denominator, and this left-hand side needs an x minus 3. So I'm going to go ahead and get 5x squared minus 15x, again, just distributing there, plus 4x minus 9, all over x plus 8, x minus 3. And again, I can combine them because I now have common denominators. So I'm going to combine the top, and I get 5x squared minus 11x minus 9, all over x plus 8, x minus 3. And I can try to factor the numerator. So I could go what multiplies to negative 45 and adds to negative 11. And I can go through some of those factors. So 1 and 45, 3 and 15, 5 and 9, and none of them work. So we don't have to worry about simplifying anything else. This would be my final answer. Number 24. I'm going to actually move this out of the way quick. Okay, number 24. Same idea, except we're subtracting. So I get x plus 2 over, and again, factoring, I'm going to get x plus 3, x plus 1, and then minus 5x over 2x. Okay, so, oh, nope, I definitely wrote that wrong. I just looked at the wrong problem. X plus 3, x minus 3. Okay, let me triple check that I wrote that right. Yep. Okay, so this one needs to be simplified on both sides, and we are missing an x plus 1 and an x minus 3. So I'm going to go x plus 1, and x minus 3, x minus 3. So on the top, I'm going to have to FOIL So I get x squared minus 3x plus 2x minus 6. And then I'm going to distribute here. So I get minus 5x squared and minus 5x. And again, I'm distributing this whole negative just to make it easier. And then all over my common denominator of x minus 3, x plus 3, and x plus 1. And then I can just combine like terms on the top. So let's see what happens. I get negative 4x squared. I get negative 8. No, I don't. I get negative 6x and minus 6 all over x minus 3, x plus 3, x plus 1. And I can't factor that, but I can remove a common factor of negative 2. So I get 2x squared, plus 3x plus 3 all over x minus 3, x plus 3, x plus 1. So a bit longer, but same idea. Number 26. Rewrite the function. Okay, so I have g of x is equal to 5x plus 1 all over x minus 3. And it wants it as g of x is equal to a over x minus h plus k. So just to remind, and then you want to graph the function. You can graph the function just on your calculator, plug it in as it is, and you should be good. I am going to not graph it because I'm confident that you can use your calculator to do that, but I am going to show you how to rewrite it. You can do this two different ways. You can use synthetic division or long division and get a remainder, and then you can also try to factor the top to match the bottom to get them to cancel. Okay, I'm going to show you the division. I think that's easier. So I'm going to use synthetic. I take this negative 3. It becomes the opposite, positive 3. And then I take my coefficients and I put them in order. So 5 and 1. I bring down the first number to start. 3 times 5 is 15. And then I add down 16. Okay, so this one's really short. This is the remainder. And this is just a constant value. So if I were to write this, it would be 5 plus 16 over x minus 3, because that's what I divided by. I'm going to use this equation to put it in the correct form. So g of x is equal to 16 over x minus 3 plus 5. So if I were describing the transformation, the negative 3 means that you went to the right 3 and up 5. And then again, you could graph it roughly. The graph would have asymptotes somewhere in there, and you would have a graph in this top corner and this bottom corner. But again, you would do it accurately. I'm just throwing that out there, and use your calculator. Number 32. Looking at number 32, 5 over x is equal to 7 over x plus 2. Two ways to do this. You can cross multiply and solve, again making sure you check your answer, or you could graph. So you're welcome to plug this into y1 this into y2 and see where they intersect. Make sure you use parentheses. I'm going to do it algebraically this time. So this would be 7x is equal to, and I'm going to distribute when I multiply this way, 5x plus 10. So subtracting 5x, 2x is equal to 10, so x is equal to 5. Again, check your answer. We should be good to go. Number 33, something similar, 8 times x minus 1 all over x squared minus 4 equals 4 over x plus 2. So this one is more complicated. Again, you're welcome to cross multiply and solve them and see what happens, or you can graph them. The process doesn't matter. Let's see what happens if we cross multiply. So this is 4x squared minus 16 is equal to, and I'm going to distribute this first, 8x minus 8. And so I would have to FOIL these two. If I was to cross multiply, 8x squared plus 16x minus 8x minus 16. And then I would get 4x squared minus 16 is equal to 8x squared plus 8x minus 16. So I'm going to move everything this way. I get 0 is equal to 4x squared. The 16's cancel, plus 8x. I can take out, so 0 is equal to common factor of 4x. X plus 2. X is equal to 0, and x is equal to negative 2. And if you check your answers, I know that this is a restriction. This is extraneous. And you can see it here when you would have factored, or you can even see it here. You know that x cannot be negative 2, so the only answer is 0. The last one, number 38. So f of x is equal to 1 over x plus 8. Determine whether the inverse of f is a function, and then find the inverse. Okay, first of all, let's just go over definitions. Vertical line test determines if something is a function. The horizontal line test determines if the inverse is a function. And this is of the original. So I'm just going to draw a quick sketch of this graph and see what happens. So on my calculator, I'm going to go in and put 1 divided by x and then plus 8 graph. So again, I'm graphing this down here. It looks something like this and then this on my calculator, okay? And again, I'm not drawing it perfectly. It doesn't matter as long as you're paying close attention to the details, but this does matter that it's a little bit higher. Okay, so first of all, if this passes the vertical line test here, then it is a function. So the original right here is a function. If it passes the horizontal line test, you guys, I drew this pretty badly because it does pass. So my sketch is pretty horrible. But pretend that this doesn't cross multiple times. If you look at your calculator, you'll notice what I'm talking about. This passes the horizontal line test. So yes, the inverse is a function. Because the original passes the horizontal line test. So it's important to be able to explain it. And then it also asks you to find the inverse. And remember, that's when we switch the x and y. So I'm going to go x is equal to 1 over y plus 8. So I need to move the 8 to the other side. So x minus 8 is equal to 1 over y. I'm going to multiply both sides by y to get it out of the denominator. So I get y times x minus 8 is equal to 1. Divide by x minus 8. So the f inverse of x is equal to 1 over x minus 8. And as I stated, that is a function. You could also graph that and make sure it passes the vertical line test. Either way, it should work.